What we have here is called a Nakamura chamber. It's a circular plastic container that has an opening up top, and we can put one fluid in the bottom. In here we have water, and up here at the top we have air, or if we wanted to, we could have oil and water, different substances. And we fill the first substance up to this line and put the second substance up top. And it's actually used to measure the index of refraction of fluids when you don't know what it is. So let's take a look at my light source here. If I start my light beam from the water, and I make it go at an angle of 30 degrees relative to the normal here. So my surface is here, so the normal is the straight up and down. And right now I've got my light beam at 30 degrees from the normal. We can see that the law of index of refraction here says that the outgoing ray, the ray that's refracted up here into the air, is going to be bent more away from the normal than the incoming. So 30 degrees incoming, and here we can see we've got about 45 degrees in the outgoing beam. So when light goes from a high index of refraction to a low, it's bent more away from the normal, so a bigger angle here. Now, we can also illustrate total internal reflection here. As I increase the angle, you see what's going to happen. We're going to get to a higher and higher angle on outgoing until we hit the angle where total internal reflection happens. And so the light ray goes up, hits the surface, and just bounces straight back. It never actually exits up here into the air at all. It's totally reflected, total internal reflection back down here. And if you want to, you can measure the index of refraction for air by noticing that that happens at an angle of about 47 degrees. We get total internal reflection. So the critical angle is about 47 degrees for plain old water. It may be different for other substances. So we can also test what happens when light goes from air into a higher index of refraction. So here, let's set it to be about 30 degrees incoming. So the incoming light is 30 degrees from the normal. The outgoing light is only about 20 degrees. So when light goes from the air to a higher index of refraction medium, it's bent more towards the normal as opposed to away from the normal. So this is a really nice way of illustrating that. Also, if we had a substance whose index of refraction we didn't know, we can actually measure it using a chamber like this.